All right, sorry to interrupt the phone discussion, but we're gonna be starting hydros. This is my favorite meeting. I presented a few meetings this semester, but like this is the one, if I could only choose one, I would just present this one, and I would only do these CTF challenges, so. All right, here's the meeting flag, I'll give you this one. And also for like the more advanced CTF players, you might know like jail is a big category, but I'm just gonna be talking about the jail in Python specific, no other languages and no other types. But Python is interesting enough to warrant its own whole meeting. All right, it'll be at the end, and I think the slides are online. All right, what is a jail? And hopefully you're not the one in jail. You might, if you're doing what Ronan does. A jail is a restricted environment that runs in the same context as the program. And the reasons why a jail versus just like total arbitrary code execution is because there's some sort of restriction placed on your input or some restriction in the runtime environment. But it's different from a sandbox, where a sandbox is run in a completely different context. So usually, even if you get arbitrary code execution, so you can run whatever Python functions you want in this sandbox, you won't be able to get anything useful out of it. The worst thing you can do is just kill the sandbox, and then it will just give it a new one immediately after. So getting arbitrary code execution in a sandbox is not useful, but in the jail, it's extremely useful. So yeah, here's a little illustration of the idea. So as you can see, you have like two different silos for the main program and then the sandbox program. And often your sandbox will have no network access, no read-write access, and all you can do is just execute code and then send as a string back to the main program. So again, even if you get arbitrary code execution in the sandbox, it's not useful. But in the jail, it's in the same environment. So if you get arbitrary code execution, you can start messing with the actual main program. And of course, there's going to be restrictions placed, otherwise it wouldn't be a jail, it would just be you have RCE on the main program, and like we shouldn't write programs like that. No one's writing programs like that, usually. All right, here's a common example. You'll see these a lot with auto graders. Sometimes when the auto grader developers are lazy, instead of doing the correct thing, you have a sandbox, you take the user code, you run it in the sandbox, you get the result, and you send it back to the main program. Sometimes what the sandbox developers will do is they'll just call exec, or they'll just call eval on the user input. That does something similar. It does execute the user program, gets the result as a string, but it's not in a different context, in the same context as the main program. So you see, like if this was an auto grader, the goal was to get you to add two numbers together. Like this is wrong because you multiply. This one's right because you make a function that takes two numbers and that looks good. So it looks like it's working. So if you're the lazy auto grader developer, you're like, this is completely fine because it passes the two tests. But you can run anything. Like they're not checking that you're just running the add 2+2 function. So you can say import OS and then os.system who am I. That runs the shell command. Who am I is just a placeholder for whatever dangerous shell command you could think of, like reading Etsy passwords or doing something, modifying the Python code so that it always gives you 100%. Like it could be anything there. This is just a stand-in for arbitrary code execution. So as you can see, this actually does run and you get the username back. And the error doesn't matter because you got what you wanted out of this program. So is this real? Sometimes. I think people are getting smart to it. I took a look before this meeting at some common auto graders. The ones I looked at were safe. I'm not going to say which ones. There are still dangerous ones out there. I'm not going to tell you which because it's very easy to do something very bad with this knowledge. But yeah, sandboxes are hard to create correctly. Like there's a lot of ways to mess it up, and then your sandbox might actually have a way to break out and get into the main programming environment. So like the golden version of that would be like a Docker escape. But there are contexts where you try to roll your own sandbox and it doesn't go correctly, and you actually made a jail. And if you're not in cybersecurity, you're just a developer, like you might look at the code from earlier and be like, oh, this does what I want it to do. So I'm not thinking of security, I don't have a offensive mindset or anything. I'm just thinking of, does this work? And it does work. So you just ignore the risks. And I'll show you at the end. Sometimes Python is an interesting enough language that you can write a jail without even writing anything that looks dangerous. So I'll show you an example of that. All right. This is the time to pay attention if you want to learn jail. I'm going to introduce a lot of things that you might be confused, like how does this actually change anything? And it's because of this distinction. There's a difference between the source code of your program and then the thing that actually gets like the content of the string at runtime. So you can look at these examples, like this one is always thought SIGPwny, the dangerous code example from earlier. And this one is similar, but I split up all the dangerous strings. So this is the source code, and then this is the result of the operation at runtime. And then same thing, I encoded as text. And you can see, even though their source code representation is different, the content at runtime is the same. So if you eval this code, it would all do the same thing. And you'll see why that's important. And then again, some basic preface on Python behavior. The get attribute function is the same as the dot. So if you see a class or an object, dot, and then an attribute, that's the exact same as calling get attr, then the object, comma, and then the attribute as a string. And that's important, it's as a string. And then, of course, the get attr command just runs the c dot under get attribute. So these are all equivalent. But as you can see, their source code representations are different. So if you're having restrictions placed on the source code, you'll be able to get around them by using counter. So yeah, remember, if you see dot, think get attr. And if you see brackets, think get item. And that brackets works both for dictionary lookups, like the one at the bottom, and then also array lookups, like the one on the top. This is kind of interesting because you'll see like actually take different types of parameters. If it's an array, it's looking for an integer. And if it's a dictionary, it's looking for a string or array. So you can store all sorts of things to the key of the dictionary. So just notice the types of become. All right. So what if on the source, they said that you can't use the word system? So all they did is they take your user input, like the program and the test example, and they search it and they say, do I see the word system? Yes? Okay, then don't run the code. Otherwise, you run the code. So what other ways are there? Well, turns out you can do similar things in Python. The Python standard library is big enough that there's other ways to run shell commands without using the word system. So here's two examples. You have popen and you have sandboxes. It's pretty much the exact same thing. So just checking for the word system isn't good enough. And it turns out there's other ways to do it, like, for example, you could split up your string. So since you can see in the last example, like these ones don't have exec. Here I added the exec. So this is in like the user provided code includes the exec. So this whole thing will be converted into a string and then exec by like the auto grading program, for example. So here, since now I have exec, I can split up the parts of my source code into different strings. So now if the auto grader or whatever is looking for the string system, it's not going to find it. Because in the source code, it reads SYS, or then single quote, then plus, then single quote, then 10. Like never did the string system appear. So this would be considered safe and it would get them. Even though the thing it actually does is the exact same. Same with the hex encoding. You see the word system anywhere here, like I don't. Even though if you converted this into a string, you would see that it's actually like the exact same thing. And it gets executed and then you run to a mine. And then same, Python has this chr function. It takes a integer that represents like the character as a decimal, the ASCII value as a decimal. So you can look up online what these are. And then the coolest one here is that Python will Unicode normalize like parts of the source. It's like the import keyword or the system keyword will actually like, even though this isn't the word system, like if you did a string compare this with equals, it would not pass. It would say they're different. But Python will fix it for you at runtime. So you manage to bypass the same trick. So this trick will work like anytime you see a character whitelist, like this will work. Or a blacklist, sorry. So if you see like a blacklist for any any keywords, this will bypass them. Because there's like a bunch of different things you could use. Right. And then here's the easiest ones, breakpoint and exec input. If you see a PyGel challenge out in the wild, try these two first. These get paths like so many different blacklists. As long as they didn't blacklist the breakpoint keyword, then you're done. You can see here is what breakpoint looks like. It spawns a Python debugger, which is basically just like a Python REPL where you can run commands. And exec input is something similar. Yep. And here I'm using, remember, since we have an OS.system, instead we can use getAttr. So now instead of having to have the whole word system appear in the source, we can have it as a string, and strings can be split up into parts. And then here's a little fun fact about Python internals. You can call this locals function to get the local variables, and then you can call this dir function, which will give you all of the attributes on an object. And then as it happens, the 283rd attribute is system on OS. So there you go. So this whole thing just calls OS.system, exact same as everything else we've seen. So like, don't worry about memorizing these, the slides are up. The way you go about solving PyGel challenges in reality is you have like a long cheat sheet that you read, and you compare your restrictions to the whole bank of knowledge that you know. So like slides like these are super useful. This is just a joke. So we've been showing exec the whole time. You might know about eval instead of exec. Both of these execute a string as source code, but the difference is that eval expects an expression, so like you only get one line, whereas exec allows you to have multi-lines. So it's a little bit more restrictive. Like for instance, you can't run import and then os.system because now you have two lines, like two different expressions. So in order to get into one expression, as it happens, Python has a built-in function called _import. You can use this if you open up like a Python file. You can use this instead of the import keyword, and it basically does the same thing as like import OS is basically OS equals dunder import OS. So now you get to import OS in one line and then immediately call system on it. And the second one's pretty similar. This assumes that you already have OS imported, which you might. All right. I'm gonna wait until someone gets it, so we might be here a while. I showed like 20 examples, so you guys know. This is This is very unrestricted. There's only three, it's a blacklist of 3 things. So if you, okay, if you don't want to solve the whole, well, how do you get strings? Okay, that's thing 1. Thing 2, you said is to split it up. All right, let's try that out. So imagine you can use a single quote and you can split up the strings if you want. Very well. Nice. So here's my solution here. I use the single quotes, and then instead of using like open and read, instead I used os.system. And then there happens to be a cat which can read files. So that works. This works for almost everything. You see this, if exec and input aren't in the blacklist, then this works. In parentheses, I guess. So there you go. That's the skeleton. Yeah. The only thing I want to highlight out of this cheat sheet, again, you might want to read all of these through at some point when you're solving PyGel challenges, but the important one is this built-ins right here, this under built-ins. Anytime you use a Python keyword like int, open, exec, breakpoint, all of those are stored in this built-ins dictionary. So like, yeah, int is equivalent to built-ins.int. So if you get rid of the built-ins, then you get rid of the int and the open and the exec, you can't use any of those things. So that's worth knowing. So yeah, anytime you see like restrictions placed on your input rather than a sandbox, you should think like maybe Python is weird enough that I might be able to abuse Python's weirdness to get what I want out of this program. Even with all sorts of restrictions, I've done challenges where all you have is like you don't have any ASCII characters and you can still solve it. Like it's a pretty easy challenge actually. That was a false ETF challenge. You don't get any ASCII letters and you can still get arbitrary codes. So here's an example where I got rid of your built-ins. So the second argument is basically like, what does the exec have access to? And I don't give it built-ins, but I give it the globals function and the print function. So if you try just doing like breakpoint or exec input, that actually wouldn't work because you don't have built-ins. So the skeleton key doesn't work for this challenge. Can we do better? Yep, so as it turns out, like globals, one of the entries in globals is built-ins. So you can just recover the built-ins directly, you get your import, and then you can solve the challenge. This one's pretty easy because we gave you access to globals. All you have to do is just do a very simple built-ins recovery like that. And then here's the complicated solution. This is if you didn't have globals. Well, it turns out that you can recover built-ins with a string like this pretty much always. You have access to the print method, which you can get the base class of with class base. That gives you the object class. And everything in Python is a subclass of object. So if you look at the subclasses, you have everything, and as it happens, the 104th entry, like the 104th subclass of the object class is the built-in importer, which lets you import things. So this like load module is equivalent to the dunder import, yeah?
So, if the OS module is already like this sort of like relative to the print module, like, why do I have to import it? Why do we have to import it in the first place? Or is it sort of this, or is this sort of like the base class is already this umbrella things that?
Yeah, I get what you're asking. The idea is that like, because built-ins were removed, let me go back. Because built-ins were removed, like I can't use the import keyword won't work and the dunder import I showed you either, that also won't work. Because those are all entries in built-ins. So since built-ins is this empty dictionary, there's no dunder import, there's no open, there's no print, there's nothing. So, but I have print. But like printing isn't, I can't read a file with print. Like that's not enough. But the whole reason why I'm using print is just to get print.class.base, and this is the object class. And as I'm talking about, in Python, everything is a subclass of object. And the thing we're looking for in particular is something that's present in every Python program, even if I get rid of the built-ins. There's like hiding in the Python internals, this is built-in importer. The subclass of object, but you don't actually have access to it. Like there's no keyword that will tell you, they give me the import of the built-in importer, or you can't get it that way. But it's still loaded in memory, so you can get it via just by checking the subclasses. Yeah. It'll make more sense if you try doing challenge like this, or you can mess around in the Python REPL, just like looking at what things are imported at runtime. Because they store all sorts of things in memory in Python. The whole is more than you would expect there. All right, less obvious fails. I promise this. Here's a classic example from FA2025. I want you all to take a minute to stop and read this code and look. Does this look like arbitrary code execution? I showed you a bunch of different examples earlier today where you use eval. Like that's obviously unsafe. If you Google eval Python, the big thing it will say is you shouldn't use this. Yeah.
You can do the username and then since in the brackets, you need its format, which is basically eval.
Kind of. You're half right. Format is not eval. Like this is actually kind of like this is surprisingly safe if you just have one format. The double format is in fact the issue, and what it lets you do. Yeah. The RCE is actually like a kind of special case, but it definitely is arbitrary to read. Like you can read any variable in Python. Alright, yeah, I'll go through the example. So this is how it's like supposed to work. Is that it takes a username from the user and then randomly generates an ID. So yeah, it makes sense. It does what you expect it to do, right? Like it fills in the username and fills in the ID number that gets randomly generated. So like that looks normal. But is there a vulnerability with calling it twice? Yeah, there is. Because format lets you modify the underlying string. So like here's an example. Like what if I set my username to ID brackets? Then after the first format call goes, then what you see is okay, user ID, parentheses ID. So to Python, this looks like, oh, I'm supposed to fill in this ID in both of these places because it matches the format in both. But in the original string, this wasn't supposed to be the ID, it was supposed to be the username. So I was able to get information into the string that's not supposed to be there because of the double format call. So here, like, yeah, you see the ID appearing twice. So yeah, this is in fact a jail because we have restrictions placed on our input or only just the way format works. All you can do is you can access attributes or methods on functions, but you can't call the methods. Yeah, or can you? In this example, like no, you can't call methods yet, but you can access attributes of attributes, which lets you dive deep in the Python internals. And we looked at an example where you can go subclass and just keep going down the Python internals, accessing different things. So you can do that in this example because of this format issue. The double format specifically. So if there was a global called flag, like in this example, it's like how are you gonna print the flag? Like you don't do anything. All you do is you like get a string formatted based on your info, like how are you gonna get the flag? And it turns out you can just grab it like this. Yep, I.init is the function. Functions always have this under globals attribute on them, which is a dictionary of all the global variables. And then one of them is the flag. So there you go, you have the flag. In this super duper innocent looking example, you were able to read a variable that you shouldn't be able to. So you can imagine instead of a flag, if this was like a secret or something, like Flask often has a secret key, you could read the secret key and you can do malicious things with that. And the no quotes is not a mistake. The format function in Python has like this super duper lightweight parser. So it's like it's not good enough to handle quotes. So they had to like redo the whole Python like access model to allow you to not use quotes. It's not a mistake. I don't know why. I don't know why they did that, but that's how Python works. All right, that's basically it for this meeting. There's several, like a lot of Pwny CTF challenges for PyGel. I recommend looking like first at the PyGel number of things. And after you're done with those, you can try out some of the other names challenges. They're all pretty difficult. I wrote half of them, and then Pete wrote the other half, and they're all pretty hard. So you might have issues, but again, try exec input, try breakpoint, that might get you through a lot of them. And then after that, look at this PyGel cheat sheet specifically. I recommend checking that out. This has like every single PyGel CTF challenge in the last like 5 or 6 years is on there, including ones I've written. So, and then of course, raise your hand. I can answer any questions you have about PyGels. All right, this Thursday we're gonna have a Halloween party, details TBD. And then next Sunday we're gonna have a seminar meeting, again details TBD. And then next Thursday we're gonna have game night. So get ready for game night. All right, or it's next Thursday. So here's the flag.